Okay, number 7, we want to make the decision whether to reject the null or fail to reject the null. So we're going to go through and we're going to combine all the steps that we've done so far. So first, we're going to identify the null and alternative. We're going to find our test statistics, and we can just find our p-value and compare it to here. But there's 2 ways you can do it, so I'll show you both. It says a political study took a sample of 800, so I'm going to go ahead and start setting this up. So 800 is my sample size. That is going on the bottom under the square root. It found that 67% were in favor of construction, so my sample proportion is 0.67, and then I have to subtract the true proportion, and then 1 minus the true proportion down here. Okay, continue reading. It says use the data. A political strategist wants to test the claim that the percentage of residents who favor construction is over 63, so we think it's more than. So this is going to help me set up my null and alternative. So P, we think it is more than 0.63, so my null is less than or equal to 0.63. And so we plug in 0.63, 0.63, 0.63. This is a right-sided test, one tail. Let me come down here. So this area right here is 0.05. We can find the critical z-value here, and we can compare our test statistic to the z-value. If we fall in this region, we reject HO. Reject the null. So basically we're testing to see, this is a number. It might be a little bit bigger than 6.63, but just because it's a little bit does not necessarily mean that it's actually bigger. You might just got a different sample. So we picked a number so that there's no doubt that it has to be greater than 60. So we're coming up with a number that's so big that it has to be definitely bigger than 6.63%. So this critical value, 0.05, we can compare that to the Z table. You go down to critical, and then it shows you here 5%. If you're doing one-sided here, if you're doing two-sided, we use this number. So since one-sided, 1.645. 1.645. So we're going to compare our test statistic. If our test statistic is bigger, we reject it. If it is smaller, then we fail to reject it, which means that the percentage we got actually could be equal to or less than this. Okay, so we're going to compute this and find our test statistic. Clear out, parentheses, we're going to do 0.67 minus 0.63, close, divided by, open parentheses, square root. We're going to do 0.63, and then open parentheses, 1 minus 0.63, and then divided by 800. Our sample size, close twice. We get 2.34. So 2.34 is going to be over here, much bigger. This falls in the rejection region, which means we reject HO. Now in the textbook, they also just allow you to compare this level percentage. Let me see. Move this calculator. They allow you to compare this confidence level. So alpha is 0.05. And what we're going to do is we're going to compare P, our p-value, to this alpha. If P is greater than alpha, we fail to reject. If P is less than alpha, we reject. So let me show you what that means, how we interpret this. According to our test statistic, we got 2.34. If we go to the normal table and we look up the area to the right of 2.34, which is the same as the left of negative 2.34, we get 0.0096. So what I'm doing is I'm comparing 0.0096 to 0.05. Okay, that's the level of error we're allowing. This is the true error that we found. You can tell that this number is definitely less than this number. So you reject HO. Both of these definitions match up. It's just two different ways of looking at it. I like comparing the test statistic and the critical value. Sometimes you will be asked to do the p-value. So anyway, this is why you find the p-value, so you can do this comparison. And that way you don't have to look up this 1.65. You just have that, and you look at that number and compare the percentages. But they both give the same conclusion. So in this case, we would reject the null. So basically we're saying that this percentage, this 0.67 we got, is much, much bigger, or big enough to say that it clearly, this has to be the case, that our true proportion has to be bigger than 0.63. So we reject the null hypothesis. We reject the claim that it has to be less than or equal to 63, and in favor of this, that it's greater than.